Hi, Assalamualaikum warahmatullahi wabarakatuh, my dear students. Today is a very important day in our lives because we are going to start learning about organic chemistry. For lesson 56, the title is Structure and Functional Groups. Let's proceed. What is organic chemistry? Let's look at the introduction for this lesson. We need to list the elements that made up organic compounds and state the ability of carbon to form 4 covalent bonds. So they will form single bond, double bond, and triple bond. And then we need to differentiate between saturated and unsaturated organic compounds and give examples for them to be used in medicine, engineering, biotechnology, and agriculture. Organic chemistry is the chemistry of carbon compounds. Carbon compounds form living things. Organic compounds contain hydrogen as well as carbon, while other elements also are included. For example, oxygen, nitrogen, halogens, sulfur, and phosphorus. Varieties of organic compounds are so vast, it's more than 10 million. They may exist as simple, complex, and in forms of gases, liquid, solid, colored, and colorless. Common elements in organic compounds are, of course, the first one is carbon of group 14, and then the second is hydrogen, the first element. Apart from that, we also have a lot of oxygen and nitrogen. We also have a lot of halogens of group 17. And then we have sulfur, phosphorus, silicon, and boron in small amount. Our bodies are made of organic compounds. Look at this little boy. He fell off his bike while riding and hurt his knee. Drug and aspirin that the doctors might give him contains carboxylic acid and ester functional groups. We can look at the structure later. His hair naturally is constructed from the protein alpha keratin containing amide functional groups. And as he falls down, adrenaline will be secreted by the adrenal glands in response to the stress. So this enzyme contains alcohol, amine, aromatic, and phenol functional groups. Let's look at the eye of the boy. The vision depends on compound cis-11 retinol, which contains aldehyde and alkenes. So we've been mentioning here most of the functional groups that we need to identify and know their reactions in our syllabus. Let's look at the chemistry of carbon. It is a basis of organic chemistry since it exists in all living organisms. Carbon is a nonmetal that can bond with itself and many other chemical elements, and it can take the form of one of the hardest substances, which is diamond, and one of the softest substance, which is graphite. Here is the position of carbon in the periodic table. Now let's listen to carbon. It wants to talk about itself.
I am carbon, and I am special. You can spend your whole life learning about me. I can form short and strong carbon-carbon bonds. I gladly form carbon-carbon double bonds, and I can even form carbon-carbon triple bond. I have no problem bonding to other elements. Hydrogen, oxygen, nitrogen, sulfur, I love them all. And the most important thing about me, given where I am in the periodic table, I typically form 4 bonds except in carbon monoxide. Means I must have 4 bonds at one time. Always remember this.
Here is a few examples of organic compounds. This is a methane, the natural gas that comes out from your mouth and from your under. And this is an aspirin, the one that is given to the boy. The scientific name is methyl salicylic acid. Another example of an organic compound, as you can see in figure 4.2, is penicillin. It's an antibiotic, one of the oldest one. And then the below part would be dichloro, diphenyl, trichloroethene. It's a DDT pesticide for agriculture. There's a lot of usage of organic compounds. In medicine, they are antibiotics. In engineering, they are diesel, gasolines as fuel. In biotechnology, genetics is all about organic compound. And agriculture, using pesticides and insecticides. That is all organic compounds. The next part of the lesson is to learn about molecular and structural formula. There are 3 types of structural formula, which is condensed, expanded, and skeletal. We need to be able to draw all 3 of them, and we need to explain primary, secondary, tertiary, and quaternary carbon and hydrogen. Now, we have learned this in Chapter 1, Sem 1. Empirical formula is the simplest formula that shows the simplest ratio of the number of atoms for each element present in a molecule. For example, CH6O. Now, this is the empirical formula for glucose. Whereas, molecular formula is the formula that shows the actual number of atoms of each element in the molecule. This is a glucose. The molecule of glucose has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Okay, let's do example 4.1. For first, organic example, coincidentally, is a question that we have done previously in chapter 1. So we have a hydrocarbon sample which consists of carbon and hydrogen as much as 85.7% and 14.3% respectively. Its molar mass is 56. Determine the empirical formula and molecular formula of the compound. So the first thing that we need to do is find N, the number of mole of each element. So we divide carbon with 12, hydrogen with 1, and the answer is around 7 for carbon and 14, around 14 for hydrogen. So we see that the simplest ratio here would be 1 and 2. Okay, so the empirical formula would be CH2. So what is the molecular formula? We need to find the molar mass for CH2. The molar mass for CH2 is 12 plus 2, which is 20, 14 gram per mole. And then we got the molar mass. The actual molar mass is 56. So N is equals to 56, the actual molar mass of the compound, divided by 14. This would be 4. So N equals to 4. Therefore, the molecular formula okay, would be C4H8. Oops, that's very big. Okay. Your next task is to do practice 4.1, and you need to find and calculate the mass of carbon, hydrogen, and oxygen in compound Y. So please, this is basically a combustion data. So you're going to have a few steps before you can get the actual mass of carbon, hydrogen, and oxygen. After you determine the empirical formula, you need to write down a balanced chemical equation for the combustion of Y. Now let's look at structural formula. There are actually 5 kinds of structural formula. What is structural formula? It's to show how the atoms in molecule are bonded to each other. We have 5 types: expanded, condensed, skeletal, 3D, and fissure. The expanded structure is indicating how atoms are attached to each other, but are not representations of the actual shapes of the molecules, because you cannot see the three-dimensional geometry of the compound. So we're going to see the bonds that is attached to each of the carbon atoms in the molecule. For example, here, please write down in your course book C4H9Br. Okay, for this compound, let's name this compound because we're going to do the naming shortly. Let's give number to each carbon. So this is carbon number 1, this is carbon number 2, this is carbon number 3, and carbon number 4. Carbon number 2 has bromine attached to it. So we name it 2-bromo, because this is 4 carbons. 4 carbon is a butane. If it's 1 carbon, this is a methane. 2 carbon, ethane. 3 carbon, propane. So this is a haloalkane which has a bromine at carbon number 2, and it has 4 carbons. Therefore, the name is 2-bromobutane. You can see the expanded structure will give us an easy visualization because we can number the carbon, because every carbon has 4 bonds attached to it. It is clearly shown here: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There are 9 hydrogen atoms. All are 9 here. We can count them all. And that's it for expanded structure. Expanded structure is the largest structure that we can draw for each of the compound. Next, this is more example for compounds of alcohol and carboxylic acid. Let's do the naming. Since we are getting more into organics, I'm going to use another red color here. Now, This is carbon number 1. We number the carbon nearest to the functional group. So this is carbon number 1, this is carbon number 2. So this compound is called ethanol because it is 2 carbon, ethane, but since it has a hydroxy group, we will add ol instead of E. Okay. Next is carboxylic acid, having 1, 2, and 3 carbons. This is carbon number 1 that is attached to the carboxyl group. So instead of calling it propane, we call it propanoic acid. So this is the IUPAC nomenclature for an example that is given to you. We actually want to show you the expanded structure. You can see that all the bonds are shown 1, 2, 3, 4, 1, 2, 3, 4 for the carbons. Here as well, we have double bonds here, and it is clearly shown. So this is basically expanded structure. Next, we look at condensed structure. Condensed structure is more simple, and for people who are doing organics regularly, condensed structure is easier compared to expanded because it would take a lot of time to draw all of the bonds. So what's going to happen is condensed structure does not show any of the bonds, single bonds between carbon and the hydrogen atoms, but double bond and triple bond will be shown. Otherwise, we wouldn't know whether there is a double bond or triple bond there. So let's move to the example 4.3, where you can write again the same structure which we have named. The name of this structure, do you remember? Now the bromine is put in bracket, and this bracket shows that the carbon before it is the carbon that is attached to it. So this is called 2-bromobutane. All atoms are attached to a carbon are written immediately after that carbon. So for first carbon, H3 is written after it. For the second carbon, H and bromine is written after it, and so on. So this is what we call condensed structure. Here is more of example 4.3. If it's not there, just add it in your course book. Cyclohexane, how do we draw C6H12 condensedly? We need to draw the single bonds still, because otherwise we don't know whether it is a cyclic compound or not. And then for aldehyde, we need to draw the double bonds in the carbonyl compound. This is a carbonyl group. So you need to draw the double bond, or you can write this CH3CHO. Basically, CHO is saying that it is representing C double bond OH, this part of the aldehyde. Okay, the third one is skeletal structure. Skeletal structure only shows the carbon skeletal. Hydrogen atoms are not written, carbon atoms are not written. The written ones are only the other than carbon and hydrogen, which is oxygen, chlorine, and nitrogen. Example 4.4 is on 2-bromobutane again. So what we have to do is number 1, 2, 3, 4, and then we draw the dot. 1, 2, 3, 4. Where is the bromine? Is in carbon 2. So bromine will be drawn here because it is an element other than carbon and hydrogen. So we do this. This is fun actually. Voila! This is the skeletal structure for 2-bromobutane. Okay, as you can see here, for this cyclopentene, this is a cyclopentene. E is for alkene. Alkene has a double bond here, so you have to draw the double bond over here. Can you see this cyclic compound? Okay, and then the double bond should be written here. Okay, the next part is a 3D structure. So for 3D structure, we have used wedge line before because it moved towards you, dash wedge before because it moved away from you, and also a standard regular line. So 3D describes how the atoms of a molecule are arranged in space. Example 4.5 is on bromomethane. The expanded structure is given to you here, bromomethane, can you see? And then this is the tetrahedral structure. The geometrical shape is tetrahedral, and you can see that the thick wedges is going towards you. The dash line is going away from you, and there is a 2 straight line. If you forgot how to draw this, you need to go back to the green book, chapter 5. Also for the empirical formula just now, combustion data, go back to green book, chapter 1. So basically for tetrahedral, since this carbon is in the middle, the bromine can move to the front side, to the back side, and to the right and left. So we can do all three as a 3D drawing. So this is the indication of how the bonds are drawn. Next is Fisher projection. In Fisher projection, the vertical lines represent bonds that project behind the plane of paper. So you have a plane of paper. So when it is vertical, it is behind. But if it is horizontal, it is on the paper. The intersection of vertical and horizontal lines represent a carbon atom, which is a stereocenter. This is example 4.6. We are drawing 2-butanol. Why 2-butanol? Because carbon number 2 has hydroxy compound. So you can see the vertical line is basically here, and the horizontal line is here. The intersection is marked as a star here, stating that this is basically a chiral center or an alpha carbon. We will learn about this further, more in the next chapters. You have to do practice 4.2 on your own first, and then we are going to discuss in the class, in the channel, anywhere. Okay? Do all the 3 expanded, condensed, and skeletal structure for the compounds given to you here. It's really interesting. Please Do it on your own first before referring to your friend's work. Next part is to know the classification of carbon atoms. A carbon atom can be classified as primary carbon, which is bonded to only one carbon. Secondary will be bonded to two carbons. Tertiary bonding to three carbons, and quaternary will be bonded to four carbons. Let's look at this example. As shown to you there is one carbon, and that particular carbon is a primary carbon because it is attached to only one carbon. This carbon also is primary carbon because it is attached to only one carbon. What is this hydrogen? This hydrogen is attached to a primary carbon, so it is a primary hydrogen. Okay. Next, we look at another example where the arrow goes there in the middle. So that particular carbon is attached to two carbons. Hence, this is a secondary carbon. Okay, where the arrow is next, oh, that hydrogen. That hydrogen is attached to the secondary carbon, therefore, it is secondary hydrogen. Next, we look at a different compound. This compound is showing to the hydrogen that is attached to a tertiary carbon. So, we need to identify this carbon first. This carbon is attached to 1, 2, and 3 carbon. So it is a tertiary carbon. Attached to it is the tertiary hydrogen. Next, let's look at another last compound which has carbon in the middle attached to 4 carbons on all sides. So this carbon is called quaternary carbon. There would not be a hydrogen quaternary because no more bonds can be formed here. It's already filled, 4 bonds. Similarly, a hydrogen atom is also classified as primary, secondary, or tertiary depending on the type of carbon to which it is bonded. And we have done all the hydrogens. When the hydrogen is attached to a primary carbon, it becomes a primary hydrogen. So as a tertiary hydrogen is basically attached to a tertiary carbon. There would be no quaternary hydrogen because carbon would be bonded to 4 other carbons when it is a quaternary carbon. Carbon can have only 4 bonds. Let's do practice 4.3 together. Okay. The question is, classify the carbon atoms for this compound. For this part of the lesson, we are going to define and classify functional groups, know what is homologous series and explain its characteristics in terms of general formula, functional group and chemical properties, physical properties, and their members. Then we need to classify and name the homologous series based on IUPAC nomenclature. Functional group is an atom or group of atoms in an organic molecule which characterize the molecule and enable it to react in specific ways. This, in turn, will determine its chemical properties. Functional group divide organic compound into classes, type of chemical reaction, and serve as a basis for the naming. Homologous series, on the other hand, is the series of compounds where each member differs from the next member by a constant CH2 unit. Members of the same homologous series are called homologs. Let's look at the features of homologs. Homologs obey general formula. For alkane, for example, the general formula would be CN H2N plus 2. Alcohol, CN H2N plus 1 OH. This OH is the group of atom that belongs to alcohol. Its name is hydroxy compound. The functional group OH is called hydroxy compound. Another feature of homolog is it differs from the successive homolog by CH2 unit. More features of homolog. It shows a gradual change in the physical properties. It would have same functional group. For alcohol, all homolog would have hydroxy compound OH. Number 5, it has similar chemical properties. And number 6, it can be prepared by similar general methods. So if you're going to learn homologous series alcohol hydroxy compound in chapter 8, all alcohol can be produced by general preparation reaction. We have a special task for you. In this lesson, you need to complete table 4.1 in page 118. This table is called Homologous Series and Functional Group, and you can get the information from the book itself, but in different chapters. Chapter 5 is on alkane and alkene. For example, chapter 6 is for arene, aromatic compound. Chapter 11 is for amine or amide. So browse through all the pages, and at the beginning part of every chapter, you're going to get the information. Or you can even use any reference book that you have with you. And you can also Google if you know how to Google. You can do this work with your friend, a partner, in order to save time, because you should spend only 15 minutes on this. So please do it now when you are pausing the video, or even later when you have finished watching the video. Thank you. Let's do exercise 4.1. Please write this down in your exercise book. Identify the functional group in the following molecules. So you can see in molecule A, it has a double bond. Double bond is the functional group. For compound B, you have a double bond and also a hydroxy group. Look at the third molecule. Isn't it a wow? It's a big molecule, organic compound, and it has a lot of functional groups. So let's look at it one by one. The top one here, C double bond OOH, is a carboxyl group. On the right, it has two C double bond O. In the middle is O. This is called acid anhydride. And this one we have done, hydroxy compound OH. This part, C double bond O and NH2, is called an amide group. This is an amino group, NH2. Here is an ordinary double bond for alkene. And here is an ester. The homologous series is ester, but the functional group is carboalkoxy. That's all for the introduction molecular and structural formula, functional groups and homologous series. I thank you for watching the video, and let's enjoy our journey in organic chemistry together. It's really fun. Assalamualaikum warahmatullahi wabarakatuh, my beloved students. Bye.